Good afternoon, everybody. My name is Sean Patchett, and I'm going to be an instructor. Today's lesson will be on weight and balance. So during this lesson, the student will be introduced to weight and balance theory and computations. Required materials for the lesson will be a rotorcraft flying handbook, paper and pen, and a calculator. So here's something to think about. If I held a 10-pound weight out at arm's length, and then I took a 20-pound weight and held it up close next to my chest, which weight do you think is going to give my body more of a strain? So basically, keeping the helicopter within its operating limitations throughout the entire phase of flight is essential for safe operations. If the helicopter is taken beyond its limitations or loaded improperly, it may be very difficult or impossible to get the helicopter safely back on the ground. So, having said that, weight and balance is an extremely important part of your pre-flight planning. An overview of today's lesson is going to be, we're going to cover some definitions, we're going to cover center of gravity calculation, and center of gravity management. So we're going to start off, I already got some definitions written up on the board, and they're going to be weight definitions. We got a lot of definitions to go through. I'm going to go through them pretty quickly here. So we're going to start out with basic empty weight, which is the weight of the standard helicopter, its operational equipment, unusable fuel, and full operating fluids, including full engine oil. Then we have license empty weight, which is your basic empty weight, not including full engine oil, only undrainable oil. And these are actually abbreviated as BW and LEW. So then we have our useful load, which is the difference between your gross weight and your basic empty weight. It includes the flight crew, usable fuel, drainable oil, and your payload. Payload is basically a term used for passengers, baggage, and cargo. Gross weight is the, next is gross weight, which is the sum of your basic empty weight and your useful load. And then max gross weight is the maximum weight of the helicopter. So a little review on those. Just define basic empty weight for me, gross weight, and useful load. So next we're going to be talking about balance definitions. So first we have center of gravity. And this up here is actually the symbol for center of gravity. Center of gravity is the theoretical point where all the weight of a helicopter is considered to be centered. Next we have the datum. This is an imaginary vertical plane or point. So here's a little helicopter diagram. It's either a plane here or it's just a point fixed somewhere along the longitudinal axis of the helicopter. So it's basically anywhere along that longitudinal axis of the helicopter. It's just kind of determined by the manufacturer. Next we have arm. And this is going to be the distance from the datum, also known as the station. Next we have moment. Moment is the force that results from an object's weight acting at a distance. It can also be referred to as the tendency of an object to rotate or pivot about a point. The farther the object is from the pivotal point, the greater its force. Next we have allowable range. Allowable range is the maximum amount of travel the center of gravity can move within the helicopter's limitations. And finally we have our longitudinal and our lateral CGs, which are basically the axis on which we base our center of gravity calculations. And why we calculate CG is to ensure that the payload and the way the payload is situated is within the operating limitations of the helicopter. So So a little review for those is define center of gravity, define datum, arm, and moment. And then why do we calculate center of gravity? Now we're going to do, so that's all for definitions there. We're going to do some calculations here. First, I'm going to give you fuel weight for avgas is 6 pounds per gallon, and oil weight is 7.5 pounds per gallon, or approximately 1.9 pounds per quart. So we have two equations that we use. First one is WAM, weight times arm. So this is weight times arm equals moment. And then we have total moment divided by total weight equals percent of gravity. So we have total moment divided by total weight equals center of gravity. So we have, say our weight 850, our arm is 2, it gives us a moment of 1700. Say we do that twice. So here's our total. So now we want to get our total weight and our total moment. So this is 1700 and this is 3400. Then we're basically going to use this calculator. This is our WAM equation here. Then we're going to use our total moment divided by total weight. So we're going to go total moment, which is 3400 divided by 1700, which gives us our center of gravity at 1700. There's really no premise to what those numbers really equal. I was just kind of showing you an equation, just so you get an idea of how it works. So the three methods for calculating center of gravity is the computation method, which we just did. There's also graph and table methods. So we'll review what are the variables in the WAM equation, and what is the equation to determine CG, or center of gravity. All right. Now we're going to talk about weight and balance management. Covered calculations. So your calculations are only accurate if your numbers are accurate. So be sure to weigh yourself as a pilot, weigh your passengers and your baggage to make sure you're putting the right numbers in there. So your effects of exceeding weight limitations. Basically, I'm going to be referring to the R22 with some of the more specifics stuff here. So if you're over max gross weight, I'm just going to abbreviate here. Over max gross weight here. This can result in structural deformation or failure if you encounter excessive load factors, strong wind gusts, or turbulence. So, deform or failure. For turbulence, wind, or loads. Now we're going to talk about under minimum gross weight. Operating under minimum gross weight adversely affects handling characteristics of the helicopter. During solar operations, you're going to encounter an excessive amount of forward cyclic to try and maintain that hover. This can also prevent the helicopter from achieving a desirable rotor RPM during your auto rotations. Basically, the heavier you are, the faster you're going to fall, the more air you're going to get rushing up through that rotor disc, thus spinning your blades a lot faster. And when you're going solo, make sure to add ballast. Put all of your gear in the passenger under the passenger seat, and if you throw a 25-pound ballast in there just to balance the helicopter a little better. So review for that section is name the effects of exceeding max gross weight, and name the effects of flying under minimum gross weight. Now we're going to talk about effects of exceeding center of gravity limitations. So, forward CG limit. Okay. Exceeding your forward CG limit, this can be caused by heavy passengers or pilot with baggage and no ballast or loading rear of the rotor mast. Also, your fuel tanks, if you have fuel tanks located after the rotor mast, your fuel burn's only going to push the CG farther, exacerbating the already forward center of gravity. So you got heavy fuel tanks after the rotor mast. You're going to notice on initial pickup excessive rearward cycle control to maintain a hover, and you're going to have a nose low attitude. You're going to have all that weight in the front. And if you take off, you're going to rapidly run out of rearward cyclic as your fuel burns, and it pushes that CG forward a lot. And basically, you won't be able to decelerate to a full stop if it gets too excessive. And another consideration is you won't have enough aft cyclic control to flare for sufficient flare in your auto rotation. So now we're going to talk about aft CG limit. Keep writing it backwards here. CG limit. Causes are a lightweight pilot solo with full fuel, or max baggage after the rotor mast, or kind of a combination of the two there. Lightweight. Baggage. This can be noticed by a tail low attitude, excessive forward cyclic control to maintain a hover upon pickup. Some effects is you won't be able to fly in the upper speed range of the helicopter due to inadequate forward cyclic to produce a nose low attitude. But however, this problem will decrease as your fuel burns. That CG moves forward a little bit. It'll help you out a little bit, but that's about it for that. Now with lateral CG, this isn't as big a worry with most helicopters due to their narrow cabin design, and basically most of their equipment is kind of installed along the center line of the helicopter. You should check it if you have a heavy pilot flying solo and you have full fuel on one side or the same side as you, or you have a lot of baggage on your side. It's always good to check. I mean, we do it on every flight, but it's not as important as the forward and aft. And some helicopters specify which seat is to be used for solo flight. R22 is the right seat. So in review for that topic, describe the problems with operating out of forward CG limit and the aft CG limit. So that's about all we have for our lesson today. Our evaluation was done with a series of questions after each topic was covered during the lesson. If you want to study up on your weight balance, study Chapter 7 in your Rotorcraft Flying Handbook. Thank you.